You're ready to go, Lee.
Looks good, Tracy. Thank you so much for having me. So welcome everybody to tonight's talk. This one is going to be a little informal and probably a little bit shorter than some of my previous presentations. You know, I didn't think there was a full hour's worth of material that could be provided about how to water ornamentals and trees, but I do want to cover some basic principles basically related to how we water our plants. And you know, when I got into this, it actually wound up being a little bit harder building this presentation than I had thought it was going to be. There is no end all be all to how much you water a plant. We know that at this point. And so I want to talk a little bit instead about how plants use water, how soil affects, you know, that watering regimen that you may utilize in your own yard, the role that roots are going to play in water uptake and nutrient absorption. And then at the end, I may give a couple little general guidelines on watering. So hopefully this one will be a little quicker and you'll leave with some information that'll hopefully benefit you in the future. So we know that water is, of course, fairly critical, not only to our own well-being, but of course to our plants as well. And while it is an abundant resource, it is one of the more limiting resources that we have. You know, we often don't see major issues on macro and micronutrients, but we do see issues with watering. We see overwatering in the landscape, we see underwatering in the landscape. So it's interesting that while it is an abundant resource, it's often a challenge to get this right. And of course, so much of the success of our plants does, you know, depend really on these healthy and really extensive root systems. Now, let's go back to September of 2019. We have since learned that NOAA has described the month of September as what is known as a flash drought. And this is basically a time zone where within 4 weeks, we surpassed 2 drought categories here in Tennessee. Now it's characterized by a lack of rain, but also high temperatures and a lot of sunny days. Sounds an awful lot like August of this year, doesn't it? And of course, we know that over time, this does deplete soil moisture. And this was a really neat gift that they had on the NOAA website that kind of progressed from September 1st all the way to October 1st. And you can see that drought ultimately getting worse and worse as it progresses on the NOAA website. And certainly many of our evergreens and our other deciduous trees did have some issues with this drought. You know, we saw junipers over here that did have quite a bit of decline, some dieback in them. We saw Leland cypress that began flagging. We saw a complete loss of arborvitae and particular soil types. But what's more important than not just the loss of those plants is to keep in mind that when we have drought stressed plant material and the defoliation that comes with that, ultimately that reduces the resistance to tree or trunk invading organisms. So cankers, wood borers, wilt diseases, and I would also probably add to that insect pest. You know, spider mites had a field day in juniper stands all across the Knoxville area in 2020. Now, we know about precipitation gradients, right? That leads to marked differences across the entire United States. Those plants that thrive in the Pacific Northwest are going to be different than those in, of course, Southern California, or even us over here in the Southeast, where we're getting roughly 40 to 60 inches of rain each and every year. The Pacific Northwest may have upwards of 70 to 140 inches a year. And of course, we know the native vegetation is gonna show these differences by which plants grow in these unique communities. Now, we're fortunate here in Tennessee to be a very wet state. Now, you know, if you'd have asked me that probably 10 days ago, I would have not said that I agree with that, but now we've gotten a little bit of rain. But it's important to note that Tennessee is quite a bit above the national average, which is around 30 inches of rainfall each year. Here in Knoxville, we are getting about 48. Nashville's the same. Memphis is a little higher. But it's important to remember that, you know, our rainfall patterns and precipitation patterns are kind of an ebb and a flow. You know, Knoxville in 2020 was super wet, and that kind of follows a year where we saw a flash drought, you know, in 2019. But even in years where we don't get abundant rainfall, such as 1986, we still are getting above the national average, which is important to note. And of course, we know little microclimates and micro pockets where we may get abundant rainfall, such as Clingman's Dome along the Tennessee-North Carolina border, can have upwards of, you know, 85 inches a year. Now, I don't want your eyes to glaze over at this image, but, you know, if you think back to the biology textbooks that you studied, you remember plant and animal cells. They're nearly identical with, you know, three major differences. Of course, the chloroplast exists in the plant cell, which contains the chlorophyll to carry out photosynthesis. Plant cells also have a much larger central vacuole that's used for storage. And they also have a cell wall, which gives some rigidity and some structure with cellulose, hemicellulose, and lignins in that cell wall. And all of these ultimately plant cells combine with one another to give us what we know as wood. And we've all seen a cross section of wood. But when we look at cells, plant cells at a microscopic level, things get a little bit different. This was actually a course I took, and forgive the bubbles, these are air bubbles. This was my lack of ability to create a wonderful slide. But what we're looking at is a plant cell in a hypertonic solution, which basically means a solution with a lot of salt in it. And these pink dye areas are the water that are actually being lost from the individual cells as a result of there being a greater concentration of salts in the solution that the cell was dropped in. And this is really interesting because we can see that these are individual little bitty building blocks that ultimately give us that wood structure and form. And, you know, you may have seen trees build themselves up, but I also find it interesting in the way in which trees break themselves down. It's often very cubical as well. So we can kind of better understand how these little bitty building blocks give us these wonderful, wonderful, you know, extravagant, large, huge structures that exist out in nature. And I liken, you know, plant growth to a well-orchestrated dance. And what I mean by that is if you go to a play or a dance and, you know, there's multiple cast members, if they're not all on the same page, that dance may not be as eloquent as it possibly could. And you may say, well, what does this have to do with plant growth? But, you know, I would argue that it has really everything to do with plant growth. The only difference is we have different players. With our plant material, we have three main players. Photosynthesis, of course, the conversion of that light energy into chemical energy in the form of sugars, so long as we have carbon dioxide and water. But the second player is transpiration, so water loss from the leaf surface via evaporation. And then finally, our third player is respiration, which is just the conversion of those sugars to starches, really to provide the energy for plant growth. And what's interesting in this is that even minor imbalances in water uptake and transport can lead to water deficits. And as a result of that, we often see, you know, the malfunctioning of these cellular processes undergoing in plant growth. Now, when we get rainfall, of course, you know, we know that a lot of that water runs off of the surface. It may recharge our groundwater, and a good amount is also lost to evaporation as well. But when we think about our trees and our grasses and our shrubs, a lot of that water is simply lost to the atmosphere through evaporative cooling. And when we take that evaporation and transpiration, we combine those two words, we get what we know as evapotranspiration. And in fact, most of the water that's utilized by a plant is lost to the atmosphere. So upwards of 97% of the water that is uptaken by a plant is actually lost to the atmosphere through these gradients or pressure gradients. Now, water is essential in plant growth. We've already kind of mentioned that. And when we think about, you know, our plants, they are undergoing mitotic cell division constantly. So they're duplicating their cells. And in order for those cells to enlarge, water is required. Water is also very critical for stomata opening and closing. So as water leaves are what are known as guard cells. So there's guard cells that protect our stomata. And as the water leaves these guard cells, the concentration of potassium ions builds up, and it tells that guard cell to close that pore in the leaf surface. And at that point, the plant will slow down or reduce and eventually stop transpiration. Now, also, when we think about transport of sugars and nutrients that are dissolved in that water, that's really critical for phloem transport. So as those sugars are going back down to areas that are what are known as sinks, water is required to do that. And of course, across membranes, water is very useful. And over time, of course, as plants build themselves up, we know that turgor pressure is what gives that tree or that large shrub an ability to actually stand erect through hydrostatic pressures. And that is ultimately the structural rigidity of the plant. And we've all seen this, right? If you don't believe in turgor pressure, stop watering your plant. You'll see wilting occur almost immediately. And that is the case with, many of these mature trees that we see over time. Now, not all trees suffered in 2019, which is kind of interesting. And I say suffered in 2019, I mean suffered from the drought of 2019, whereby we saw the effects of that in 2020. So a lot of these images you may notice were taken actually at UT Gardens, an area that's very carefully managed for water control, an area where they kind of understand the soils in that area and what the watering needs are each individual plant. So it's important to realize that just a little bit of information can go a long way. Now, soil texture and soil structure are very important, in determining how water moves through a system. We've all seen the soil texture triangle, right? So the aggregates that are in the soil, clay, silt, and sand. So as these form, of course, we get what is known as soil structure. And this is over longer periods of time. And it's how those aggregates actually form and connect and hold and bind to each other. So it's easy for us to see how columnar soils may be a little bit different than our massive soils and how the water is going to flow through these individual systems. Now, when we also keep in mind too, that a lot of construction really changes oftentimes for the negative, this soil structure that may have been built over many years, decades, or even centuries, when we come into a new environment, we change that soil structure, it's important to note that that is going to, of course, change water infiltration patterns. Now, soil texture and soil structure combined together give us our permeability. We know sand's the largest, clay's the smallest, aggregate. And ultimately with sand, we get a high amount of water movement through the system, whereas clay, a much smaller particle, leads to much less permeability. Now, roots are also important, not just the soil. We know that roots anchor our plants to the ground, but they also provide absorption and transport of both water and dissolved minerals. And they are also storage structures as well. Now, we have this idealized version of what tree roots look like. Often we're told they're mirror images of the upper canopy with a strong, deep central tap root that may go down for many, many feet with lateral branching off of that. And while that may be true in certain species in certain areas, most of the stuff we're looking at looks much more like this. And I would actually argue even more so like this. Upwards of 90% of a tree or shrub are going to have roots that exist in that upper 3 feet of soil. Now, it's also important to note that roots are ephemeral structures. So they come and they go depending on the environment. So if this tree were growing roots maybe over towards an area that had a lack of water, those roots may venture their way over there, but come to realize that there is not a tremendous amount of moisture in that area. In response to this, the tree may put more roots out in maybe a different area. Maybe this side of the tree has a tremendous amount of canopy coverage, so there's greater soil moisture retention here. So we may see more roots actually pronounced in this area. Now, when I talked about the cellular level of plant cells, it's important to realize that those individual cells exist all the way down here from these absorbing roots all the way to the tip of that canopy. But not all roots are created equally. Within our A zone that I've defined here, and this is an arbitrary location, it varies depending on the size of the tree and the species, but closest to the trunk, we have those structure roots. Those are the roots that actually anchor that tree to the ground. This is what an arborist would tell you. This is the do not cut zone. Do not get into this area because you will lead to structural instability of the tree. And obviously any roots that are severed in here could lead to severe malfunctioning as a result of lack of water uptake. But beyond that, we have the transport roots. Now, these are long distance roots that are carrying, again, water and dissolved minerals throughout that root system to the canopy itself. And beyond that, we have the absorbing roots. These are the actual feeder roots, the drinking roots for the tree. And some research has shown that these roots can run actually 2.5 times the height of a tree, not just necessarily to the drip line like we often try and protect. Now, does that mean there aren't absorbing roots within this transport area or this structure area? It doesn't. There are going to be some small amount of absorbing roots in these areas as well, as they venture through the soil to seek out soil moisture. So how, when I'm talking to a homeowner or a client and they say, well, Lee, I just dug down a few inches, it wasn't that deep, but maybe they cut through one of these transport roots in doing so, and it may have only been a 2-inch root. But keep in mind that little 2-inch root may well have severed thousands of absorbing roots from that tree. So we show up as a diagnostician to try and discover why is the tree wilting, or why has a large section of the tree died? And that can always be a challenge. So again, be careful. Remember that the critical root zone usually does extend out past the drip line slightly, but even knowing that roots are not necessarily this ideal image of the tree is important to know when you're making any vast changes in the yard. So how do we create successful plants? Really it just boils down to healthy and extensive root systems. Hopefully at this point you've looked at some of these images and can see that these are probably not ideal examples of an extensive or a healthy root system. This was a red maple tree, and I think this is a really telling image that kind of supports the previous slide. This was about a 5-inch red maple tree in a small planter pit between a sidewalk and a wonderfully lush lawn that I visited. And what you can see is that there was a little bit of water runoff that kind of held in this front pocket. You see the dark color. And that was just as a result of runoff that led, across the sidewalk and kind of settled in this area. And what you notice is these roots really sought that water out in time. And in fact, these roots did, I'm imagining, are starting to go up underneath this sidewalk into the homeowner's front yard. So that's important for us to understand that really tree roots are not this perfectly symmetrical version of the canopy. We also see transport roots cut down here in the bottom. We see very obvious transport roots that have nearly zero absorbing roots attached to them. Now, this was a unique situation where runoff had basically exposed these roots year after year, and any absorbing roots that were connected to these transfer roots or transport roots had since died. There were many dead absorbing roots in this area. And of course, we know downspouts at the base of plants can be really detrimental. Nick sent me a wonderful image of some pines, white pines, that, we as arborists work daily with trees. So we better understand the differences in deciduous tree root systems and some of our evergreen tree root systems. As we get saturating soils, certainly trees are more vulnerable to wind throw, particularly white pines, which, as you can see here, can be 15 or 20 years old and really only have about a 4-foot by 4-foot area of roots. And of course, as diagnosticians and arborists, we go out to sites where this type of situation happens a lot. You know, look at the size of this root. You know, these are structure roots. This is a problem not only for us trying to diagnose things, but it really can be a hazard for a homeowner that's moving into a property and then wonders why their tree suddenly goes into decline. And also remember that tree root damage is no different than injuring the trunk of the tree itself. It invites wood decay organisms just as quickly as does, you know, that tree trunk itself. So creating healthy and extensive root systems is critical. So how much should I water? You know, this is what everyone probably showed up tonight to better understand. And the answer is it varies greatly. You know, I can't give you an exact amount that you need to water your plant. The species matters, the age matters, the size of the plant, precipitation patterns in your area, humidity, exposure, airflow, slope, drainage, rooting depth, irrigation. All of these matter in how much water should be applied to our plant stock. Now, there are some general rules of thumb that I can give. Number one, we want to irrigate just enough water that's going to replace what the plant has used. Now, we can't answer that necessarily just by, you know, walking around our yard. But I think it is important to note that, you know, most plants, especially new ones, are going to need about 1.5 gallons to 2 gallons of water per diameter inch of trunk, measured at 6 inches in height. Most of us buy trees as a 2 or 2.5 inch root ball, or tree trunk, 2.5 inch tree trunk. So, you know, anywhere from 3 to 4 gallons of water are going to be required to supplementally water that plant. Now you may say, Lee, well, how often? Well, again, that takes us back over to this category here and the factors that come into play. There's no set amount of supplemental water that should be applied. Now, mature plants, they're a little different, right? Mature plants generally are going to have most of those roots in the upper 3 foot of soil. But actually, some studies have even shown that really the upper 10 to 12 inches can be the greatest concentration of absorbing roots, generally because of our watering patterns. So you really need to get moisture on mature plants down to about 6 to 9 inches, maybe 12 inches if that's feasible with your soils. But remember, even these numbers can change. The demand increases greatly on these sunny, hot, windy days that have really low humidity. That is what our flash drought in 2019 showed us. So how much do I water? How do I determine when to water? Well, I'd encourage you to buy a soil probe. You know, go out, take a probe, look down 6 inches in the soil and see if that soil is moist. If it's moist, you don't need to water. If you pull out that probe and it's dry as all get out, crumbles in your hand, it's probably time to water. Second, we have another high-tech tool, our very own fingers, right? We can dig a small hole. We can look down in that hole. We can feel that soil and determine whether or not it's moist or if it's dry. Now, we also have outward observance that we see. So if you walk out and you ever see your soil cracking, that can be a really good indicator that the soil is extremely dry, and it probably is a good idea to go ahead and water at that point as well. Now, I also encourage people, I know some of you have been on previous talks with me before, and I always encourage a perk test so you understand how drainage patterns are in your actual soil. If you've got slow draining soils, work with plant species that are amenable to that. If it's a quick draining soil, same scenario. So when do we need supplemental irrigation? Well, in new plantings, we know it's mandatory, right? A lot of our trees lack root systems. Monitor those new plants very carefully. You're going to see wilting early in life, and you've got to be very aware of droughts. Also, remember that root growth can be pretty tremendous if the tree goes in the ground properly. Anywhere from 1.5 to 3.5 feet per year is realistic. So as a result of that, we have to understand that when we water, we're not just watering the root ball, but we're watering well beyond and into that expanding root zone. For our established trees, simply irrigate those as needed. You know, most established trees don't need a tremendous amount of supplemental water. But if we get to an area like the 1st of August where we're not getting a lot of rainfall and we've got hot, sunny days with wind flows, go out and check your plants every 7 to 10 days. Monitor that soil moisture from spring all the way till soil freeze. Understand that wilting could occur. Be aware of droughts and generally water within the drip line of that tree. And also, I know I've mentioned before, but the benefits of mulch just can't be understated on our trees. That helps preserve that soil moisture. So when is the best time to water our plants? You know, early morning is a really great time because we have less evaporation. We also have a greater ability that if any foliage does get wet, that early morning sun is going to help to dry out that leaf material quicker, which will reduce disease pressures. And of course, early mornings also more efficient because there's less wind in the area. But late evening or nighttime can even be a good time to water. Now, with night or evening watering, it is important to not spray that foliage because that foliage will stay wet all through the night, and that can increase some of our disease pressures on the foliage. Of course, in the evenings, we have greater efficiency of our sprinkler systems because fewer people are using water late in the evening than early in the morning. And of course, the heat of the day is not upon us, so we have less evaporation in the evenings as well. Now, does that mean you can't water outside of these times? Absolutely not. You know, like, when's the best time to cut down a tree? When your axe is sharp? Well, the same kind of applies to some of our plant material and watering. When do you water your plants? You water when you have time. Watering at any point is better than not watering and allowing them to wilt fully and ultimately become, potentially predisposed to some of those trunk invading organisms. Now, you all have probably seen these images as well, how to water. These are kind of the non-ideal ways to water. We see this a lot where a hose is just dumped until the planting hole fills up with water. Not great, leads to root dieback and anaerobic environment. We'd never want any of our water spraying against the trunk. And I've mentioned before, the watering bags, while they are great in idea, I think they really, number one, put the water in the wrong place. So they just encourage those roots to continue to girdle and go around in circles because that's the area that's moist. They also can create a lot of shade, which can lead to sun scald once the bag's removed. And they love to harbor pests. So if you're going to use a watering bag, I would encourage some of the flatter donut style for the first few years of the new plant life. But as that tree matures, I want you moving that watering system to something that's more appropriate, such as a fountain style sprayer. I love these because they get a huge swath of area or lawn wet. They really create a fairly uniform watering system. And the nice thing is you can put them where they're far enough out so that the overspray just barely starts to touch that root ball. So it doesn't flood the root ball itself, but it really saturates the whole area around the tree. Now, what does that look like? Well, on a mature specimen, something like this. And maybe when we see that this is our entire landscape bed and we have a nice tree here, I really want that fountain sprayer kind of out here at the extremities of the drip line, even on new plantings. Let some of that sprinkle drop down here into the trunk, but don't just flood the trunk itself. And the reason I say that is because these roots are, of course, going to respond to that by growing out towards that wet environment. It's going to decrease your chance of girdling roots, and it's going to really encourage trees to radially space out their root system and create really large buttress roots like we saw, a few slides back in that Anchorage photo. Now, we hear right plant, right place all the time. This is a little bit old on the research side. I mean, it's from 1997, and I'm sure there's other, and this is not an extensive list of every tree that's suitable for a wet site or a dry site, but I think this is a pretty good list of many of the common species that we use. If you have a wet soil, start with trees, species that enjoy wet sites. If you have poor drainage, utilize these species as well. But if you have a notoriously dry site or a hillside, steep slope that dries out early, use some of these dry species. It will really go a long way towards your management and your water regimens over the long run, and reduces the amount of time you have to put into that tree. So to conclude, I think there's 4 basic points I want you to take home. Number 1, observe your plants. Go out into the yard and look at them. We manage our lawns every single week, but with trees, it seems like they fall by the wayside so easily until there is a problem. Remember that water demands and water loss really depends on the environment that tree's growing in and the species. Monitor soil moisture. There's easy ways to do it and there's high-tech ways to do it. Really, you can go out with your finger and find out if the soils are dry or if they're wet. Understand how water moves through your soil. Do that perk test. It's not a hard test to do, and you can see what drainage looks like in your area or your planting zone. Understand evapotranspiration. Monitor local weather patterns. Remember, hot and sunny days, windy days are problematic, and periods of low humidity are really a challenge for our plants. Think in terms of yourself almost. If you were forced to stand in one location all day long through the first part of August, you probably wouldn't be very happy. And the same kind of equates to our trees as well, and shrubs, of course. So if it's been unbearing hot, just get out and look at your plants and see if they're at wilting point. And then finally, choose plants appropriate to your soils. Really, this can't be understated. If you start plants off on the right foot, if you plant them well and you have them in a really nice mulch bed, that's going to go a long way towards you having to do less work over the long run. Because once a plant gets established, it usually is fairly hardy unless we just get a very extensive period of drought. And with that, I think I'll conclude and show kind of what I would consider an ideal image. I know it's a little extensive on the mulch side, but this is really what trees want. This is how trees thrive. And this is a situation where there's no competition and there's abundant soil moisture that's going to be retained after a heavy rainfall event. And with that, I'll say thank you, and I will be happy to take any questions there may be, and we can spend as long as we'd like, or move on from there, Tracy. So thank you.
Thanks, Lee. As usual, that was very informative and I learned new things. I always do. I appreciate you. So Nancy has something here in the chat, and it says, I recently bought a Corona root irrigator, which is a spike that can be twisted into the ground and then attached to a hose to deliver water. Do you have any thoughts on these? Used with established trees versus new trees, for example. The depth option is up to 24 inches.
Yeah, so that's a good one. I haven't actually heard of the Corona root irrigator. That's a new one. So the challenge with that, Nancy, is going to be, how do you know you're getting it in a location where the majority of the absorbing roots are? I'm not against it. I love the idea of being able to get water down 24 inches. That certainly is good. However, the challenge is, how close are those holes going to have to be made in order to saturate that soil? That would be my biggest issue with that. I kind of would liken these maybe to the tree spikes. You know, I often hear people want to put tree spikes in the ground to fertilize their plants. But there again, if you're putting them in the wrong location and there are no absorbing roots there to actually take up any dissolved minerals or nutrients, you know, how effective is that going to be? I really would probably, Nancy, still encourage more of a broadcast style spray. And in reality, what you can do is if you're using a broadcast sprayer, is, you know, and often people say, well, how do I know when I'm at a depth of 6 inches of soil moisture? You can put out a pie pan, turn on your water system, your irrigation or fountain sprayer, and put a pie pan somewhere out in that drip line and just time how long it takes you to put an inch of water in that pie pan. You know, if it's 15 minutes, well, you're going to have to do that, you know, to, you know, basically 4 times to get you down to that total of, you know, I guess 4 inches. So, you know, so that kind of is important more so than maybe just hitting one area with water. I'm kind of torn on that one, Nancy. I don't know for sure. I've not seen that. So does it actually creates just a small hole in the ground that you do twist and then attach a hose?
Yes, you can, and you can, the idea is like on an established tree that you move it around to different locations and water for a period of time, then move it to another location. So
yeah,
I've just gotten it. I haven't really used it yet. And luckily it rained, so.
right. Well, you know, the only problem that I could foresee with that would be potentially inconsistent watering. But again, roots are ephemeral. So if you are getting roots down there deep in one area on a regular basis, you know, that may well encourage some great feeder root growth in that area. So, you know, I would like to see those. I haven't really seen any work done on that necessarily, but you know, with a mature tree, I really feel like you're going to be better having, you know, kind of a fountain that covers this whole 30-foot radius, as opposed to just hitting one little spike that hits a little water pocket here. But, you know, if you're being careful with it, not drilling it through any major transport routes, I don't think it would be a problem. I just wonder how accurate it's going to be.
Okay, thank you.
Yes.
Lee, when you say low humidity, do you mean like less than 50%?
Oh, that's a good question. You know, so I didn't look at actual numbers there on that. I guess what I mean is just dry days, you know, when it's hot and dry out, that is kind of a killer, especially for evergreens, especially when you add in, you know, basically wind as, you know, in addition to that. That's when we see wind burn on many of our evergreens. So I don't have an actual number there to spit out, honestly. So that is a good question, though. I might could double check on that and see what exactly is defined as low humidity.
I mean, low humidity in Knoxville is a little bit rare, though, isn't it?
It is. It absolutely is. But if we have a tremendous amount of, you know, again, heat and wind, that's what startles me for plants.
I have a question about appropriate trees for an area that I think is going to be very dry.
Okay.
At our church, where I'm kind of the grounds manager, we unfortunately have a development next door.
Okay.
And the town of Farragut only required a 25-foot buffer zone, which of course the developer violated. But more importantly, he built about a 12-foot retaining wall at about 30 feet from our property line. And the way the retaining wall was built, it was backfilled with limestone gravel.
Okay.
So on the edge of this buffer zone, on the east side of the buffer zone, there's a vertical stone wall with
Right.
about a 10-foot zone full of limestone gravel behind it, with maybe 3 feet of clay soil on top of it. So I'm before this development is done, they're going to be required to plant trees.
Yes.
And I'm trying to figure out what trees can we plant or have them plant in that buffer zone next to all this, or in all that gravel zone,
Right.
and possibly survive over there. It's
Yeah.
going to drain like crazy, and it's going to get the morning sun and be hot and dry.
Okay. But is it going to, hopefully it'll have some afternoon shade. If so, that will at least be
Yes.
beneficial. Okay, good, Jerry. You know,
Yes.
that will definitely be a very well-drained soil, as far as exact species, I mean, that could be a little tricky. I mean, certainly, that's going to be an issue, not only for drainage, but I could see an issue with pH climbing as well. If there's a tremendous amount of that, crushed limestone in there as well.
Would juniper be a good choice there?
So junipers do like well-drained soils. That is a very good option.
They like limestone too, I think.
Yep, that's exactly right. And actually some junipers are fairly, pH adaptable. They're not super picky on that front. I think a juniper would be a good option. And we have a couple different publications, Jerry, that talk about, kind of those columnar junipers, since it sounded like you didn't have a ton of space in there, to try and keep them a little bit, more narrow, if you will. I think that would be a good option, certainly. Hollies are pretty tolerant too. I love hollies because they can cover a wide range of environments. So hollies could be another good option. Cryptomeria may be another one. Those Japanese cedars, of course.
No, thanks. I want all natural, all native trees.
Okay, well, then eastern red cedars would be great. They grow in cedar glades,
Yeah, that's what I'm thinking.
Bring in some ticks, but a cedar tree in a super well-drained soil could certainly thrive as well. So yeah, I think junipers and cedars could certainly be good options for you there. Maybe, one or two deciduous trees as well, but yeah, I think any of those are good options for sure.
Okay, thank you.
Yes.
We have a
Jerry-
question. Oh, go ahead.
Yeah,
Sorry.
Jerry, if you want, email me and I can help you work through a list on that if you'd like. I'll be happy to grab some of these pubs and I can look through the DER manual and better understand those that are going to do
Well,
great.
we're particularly interested in evergreens in order to shield the view from our memorial garden of our church property into the development next door.
Okay.
So I think bushy junipers and hollies, if they would live there, but you've got holly in the wet sites. I don't see this being a wet site.
So hollies are very adaptable. They probably should be on both sides of the list here. I think holly is a very, very vague term. There are hundreds of cultivars of hollies, some more tolerant than others. So I think it probably should have been like the willow oak and kind of included on both sides, but I just pulled these lists from, a paper that I had found. So I think there are hollies that could work as well, but if you want, Jerry, seriously, email me and I can work with you on a list for that.
Okay, what's your email, Lee?
Yes, sir. So it's drumble@utk.edu. And I can, drumble@utk.edu. And if you can too, Jerry, maybe kind of in your email briefly describe, the width and length that you're trying to fill. And, I can think of some other options as well. But you want to stick with natives, so that's certainly acceptable. So.
Yeah, bushy shrubs would be good too.
Well, viburnum could be an option then as well. Viburnum's like a well-drained soil, so that could be another suitable option. And they get, fairly large in size. In fact, some people don't like viburnums because they get so large. But
Like maple leaf viburnum.
yeah, there you go. That's a great one.
All right, thank you. I'll
Yes.
email you.
Okay, great. Looking forward to it. Thank you.
Okay, we have a question in the chat from Alona, and she says, I heard that when you fountain spray a tree that has a lot of grass around the trunk rather than mulch, that the water is taken up mainly by the grass. What are your thoughts?
I think that is 100% accurate. And the main reason why I say do not have grass beneath your trees. I know here in the South, we love having grass that grows right up to the trunks of our trees. But when we look at many of our species that we've cultivated from native forest species, you know, how much grass is growing beneath our native tree species in these forest stands? And, you know, the answer is zero. Trees just don't compete well with grass. You know, yes, if you fountain style spray, you're only, you know, if you run that for 20 minutes, you're just watering the grass. Now, that said, a lot of absorbing roots are within that upper 10 inches of soil. So you're going to get some down to the trees. But what I would encourage, Alona, is rather than run, I don't know what you're running it currently or what, you know, maybe run, but you're probably going to want to double or triple that. And again, that's where a soil probe can be so helpful. Go out, take a probe down 8 or 9 inches and see if that water is even getting to that depth. If it's a thick turf grass, it probably is going to be taken up primarily by the grass.
All right, do we have any more questions? Oh, there we go.
I got 2 questions if I could.
Okay.
Someone once said that the best thing for a garden is a gardener's shadow. And I really believe in that. So to really see things, what's happening in your garden, you really have to get around there and have a good look at things. And I went past a couple of ball cypresses the other day that's been in the ground for about 5 years.
Okay.
Well, you know, I just ignore them because they're established, you know.
Right.
Well, but I mean, they become deciduous. I'm thinking, mid-August is a little bit early to be deciduous. So I'm a bit worried about those 2 guys. So anyway, the second thing is I visited a garden once, and this was like a Japanese plantsman. I mean, this guy was a guru. And every time he plants a tree, he has a bit of like, I don't know, 1.5 inch PVC tubing that has a lot of holes drilled in the side of the tube. And whenever he plants a tree, he puts this PVC tube down like on an angle to the center of the bottom of the roots.
Yep.
And he uses that tube to put nutrients and like fertilizer and water into the roots so that they get down to the bottom there.
Okay.
Have you ever heard or seen that technique before?
Yeah, so I have seen that, Fred, and you know, I'm a little bit challenged by that because, you know, as plants mature and tree roots mature, they actually have a coating known as suberin, SUBERIN. And suberin is almost like a wax that covers the roots, and it really kind of inhibits water uptake. So again, structure roots are not drinking for the tree. The structure roots do not drink for the tree. Only those absorbing roots, which are not at the base of the plant, are doing the most effective work. I probably would, you know, I don't know how long that would be effective by inserting water and nutrients right at the base of the plant. It may well be enough that some absorbing roots do still form in that structure and that transport area, but I still feel like that's a little too close to the trunk to be applying the water. The nutrients, maybe there's enough, you know, again, absorbing roots that are taking up that supply. But the roots, I don't know how effective that would be that close to the tree trunk. Now, with the bald cypress tree defoliating early, you know, that's certainly you know, that's part of the process. You know, you could say the same thing about black cherry trees, Yoshino cherry, or flowering cherries. All of them are already starting to defoliate this time of year. So, you know, again, you know, depends on what we consider beautiful and what the plant considers beautiful are kind of two different things, you know. The reality is the plant's trying to go ahead and prepare as early as it can for winter, and that happens through, you know, dropping those needles, storing those sugars, pushing them down into the crown, into the roots, and getting ready for the winter. So, you know, just because a tree goes to bed a little bit earlier than some of our others doesn't necessarily mean it's a bad thing. Now, it can be an indicator sometimes, Fred, of stress. So if there were severe root injuries or maybe a trunk cavity or injury there, you know, that could lead to some early defoliation. But I don't think it's the end of the world to see a bald cypress going dormant a little bit early. So yeah, I don't know, but you know, I'm a little more torn on maybe the tubes underneath the plant of the tree. I would really rather see that water being applied out near those absorbing roots.
Okay, does anyone else have any more questions? Okay, I'm going to stop recording now.